Alright, so we are trying to find the cation anion radius ratio when the coordination number is 6, which is also known as the seem to be a octahedral site, right? Sorry, octahedral site. An octahedral site of this sort, we are basically having what's the name? A site something like this. This is the basis of the whole octahedral site, right? And then we have this, right? And then it moves up this way again. It's from this corner, and then here, the visible line here, right? But then what happens is that we are having the anions at the corners, right? Or the vertices, right? And then we are having our cation just at the center here, right? But now for us to actually find the lower limit of this when the coordination number is 6, we just pick the base, which is this side, just this side, right? So what happens here is that we have anion. The actual sense, they have to be in contact, so something of this sort. Let's make it a bit bigger, right? And then we have this here, the cation, right? So this has to be. We end up getting something like this when we make an expanded view, right? So it's this way. So this is what we have, right? And then when we join their centers, the center of the center of the anion spheres, right here, here, we get this triangle. Most of the times, for all the problems, most of the times we use triangles to find them, right? And then we have our anion here. So this was going to we are going to do. We will get this. We know that this side here, from here to here, is the radius of the anion. The same thing here. So meaning that this whole length here is going to give us something, and then here to here too is another radius, right? Here, two radiuses, right? And by here, that's what's happening. From here to here, we have one radius. From here to here, we have two radiuses of the cation, and then from here to here, we have something else. So let's see. That's right, to make it clear. So this is what we get. We have here to be two radius of wall anion, right? And then for this side here, you have radius of wall anion, and then for this side here, radius of wall anion, and then this right side, you have two radius of wall. Let me use red to make it clear. We have two radius of the cation, right? And then here again we have two radius of the anion, right? Looking at this, we can make our work very simple. Pythagorean theorem, where we have something of this sort. Let's see. So the proven, we just have to understand, have visualized the the particular site in mind, or the coordination number something in mind, and then go on with the mathematical something. Quite easy, right? So that's what we get. By Pythagorean theorem, we know we have this adjacent squared, and then we have the opposite squared, and then we have the hypotenuse, giving us the hypotenuse squared, right? Let's see if this is 1, this is 2, and this is 3. We have our hypotenuse to be this side, 3. We have our opposite, if there's an angle, our opposite will be this side, which is 2, and our adjacent to be here, which is 1, right? So now we've identified all that we need to find this. So now let's move on and then do the computations. Let's see. So now we move on to the computations. So now that we've identified from the diagram the part that we need, and then whatever we need is given. Now let's move on. Let's go back and then do something. Yeah. So this is what we have for the adjacent, which is we've already identified to be this one. We have 2RA, right? And that's squared. And the opposite is 2RA again. 2RA squared, right? This is squared. And the hypotenuse is looking at it very clearly, we have 2RAs. So 2RA plus this 2RC. 2RC. 2rc squared. So this is what we actually need, because our aim is what? RC over RA. This is what we are trying to find, right? So we have to represent everything in terms of this, right? So yeah, so this is what we need. So then again, visualize the what do you call it, the site in mind, or the coordination number diagrams in mind. Have it in mind, and when you have that, it makes your work much more easier, right? So let's put that here. So yeah, so now we have this. Now that we have this, we can move on and then do some math, right? Our aim is what? RC over RE, right? Meaning that you have to make sure we open up everything, remove brackets, squares, and everything to make our work easier, so we can group like terms and stuff, right? So that's what we do. Looking at this very well, we have to take this square out, but these two are similar, so we end up getting what? 2 of these, which is 2RA squared, right? And what do we have here? We have 2RA plus 2RC squared. If you want to make your work less confusing, whenever for the radius of the anion you can use A, for the radius of the cation you can use C, right? So this is what we get. If we try and find the square root of this, right, this here will be this whole, right? But then the square root will break down, affect this, and then affect this, right? So this 2 takes care of this. So this is what we get. We end up getting 2RA times square root of 2, right? And then we get here 2RA plus 2RC. Then again, our aim is what? RC over RA. Then we group like terms, right? So we have this and then we have this. So let's bring them together. So we have 2RA, right? Square root of 2 minus 2RA, all equal to 2RC, right? Bringing the RA out, 2 square root of 2 minus 2, right? And we have 2RC. Our aim is what? This RC over RA. We have a RC here. So if we bring this RA down, so our aim is to bring this RA down, right? And then we bring this R2 down here. So this R to be RC over RA will give us, then let me write it clear. This is what we get. RC over RA, the A coming down here. Then we have this 2 square root of 2 minus 2 all over this 2 coming down. So this is what we get, right? So now let's see what we get for RC and RA. So RC on RA, RC on RA will end up giving us what? Let's check this. Then again, have the diagrams, or be able to visualize the, what do you call it, the site, the coordination numbers, and from there you'll be able to deduce everything and get the lower limit, right, or the limit. So this is what we have. So it's 2 root 2 minus root 2 onwards 2, right? This here. And what is that giving us? 0.414, right? Yeah, so this here is the lower limit for the coordination, the lower limit of the cation anion radius ratio when the coordination number is 6. Yeah. Alright.